Chapter 4, Section 2, Angles of Triangles. And this time, instead of using a PowerPoint, I'm going to show you the book. Okay, so Angles of Triangles starts off with a little bit in here, the triangle angle sum theorem. And let me tell you ahead of time, almost everything in this section I've mentioned when I was explaining 4.1 to you. So kind of a little bit of a review. So this cute little robot does 3 pivots and makes a triangle. That's how they're showing you a real world triangle. Okay, well anyway, the triangle angle sum theorem is a fancy way of saying all of the angles in every triangle add up to 180 degrees. The measure of angle A plus the measure of angle B plus the measure of angle C equals 180 in this triangle down here. In each one of these pivots, whatever angle this little robot goes at, if it goes in a straight line and then pivots and then goes in a straight line, pivots, and then returns to its starting location, all 3 of those pivots, the angle that it turned, those angles will add up to 180 degrees. Okay, and then I'm going to skip something real quick. I'm going to go to the last page of this section and go and tell you about these corollaries. That it's kind of like when you have a main idea and then you have like some shoot off ideas that you're reminded of when you think of the main idea. So the triangle angle sum theorem I just got done telling you says that every triangle, the 3 angles add up to 180. So corollaries that come off of that are for these 2 special case. Well, this one special case for the first corollary states that if you have a right triangle, then the angles that are not 90-degree angles, those 2 acute angles are complementary. Which if you think about it makes sense. Remember that complementary means that those 2 angles have to add up to 90. Well, if angle C is the right angle and it's 90 degrees, in order for the whole triangle to add up to 180, the other 2 also have to add up to 90 degrees. And so this serves as a sort of shortcut. If you knew the angle A was 30 degrees, then you don't have to take 30 plus 90 is 120, and then take 180 minus 120 to find out the angle B is 60. You could just right away know it's 60, because if angle A was 30 degrees, and this is a right angle, then that means this has to be 60, because 30 plus 60 will give you a 90, the other 90 degrees, and that's what the corollary is letting you know. The second corollary, which is an offshoot of the triangle angle sum theorem, I mentioned it last time. When you have a right angle, a 90-degree angle inside one of your triangles, if you have a triangle that has one 90-degree angle, you can't have any more 90-degree angles. There can be at most 1 right angle in a triangle. And the other part of it says there can be at most 1 obtuse angle in a triangle. So if angle L is obtuse or right, then J and K have to be acute angles. That's what that is. Okay, so all of that has to do with the triangle angle sum theorem, which was the very first thing on the first page of the geometry section. Every now and then I like to show you, like, hey, you can read the book and look at the examples. They're basically the same thing as the PowerPoints I go over. This is proving to you why the triangle angle sum theorem is a thing. And we haven't done any geometric proofs yet. I'm saving that till December. That'll be something we're going to go back to and talk about. Here's an example where you use the triangle angle sum theorem, and basically they've got a couple of triangles connected. I have some other examples I'm going to go over though instead. I can let you look at that example if you decide to read the book on your own to get more information out of this. Okay, so there's 2 main points in this section. The first one was triangle angle sum theorem, and the second one is this thing called the exterior angle theorem. The exterior angle theorem states that when you have an exterior angle on a triangle, the measure of that angle is going to equal the sum of the measures of the 2 remote interior angles. So angle 1 would equal the measures of angle A and B. And I kind of skipped over, like, okay, what's an exterior angle of a triangle? What are remote interior angles? So if you have any triangle, and let's see if it lets me draw a triangle here, how well I can. Oh, that's not a triangle. Oops, undo. I just wanted to draw a triangle real quick. Maybe I can, maybe I can't. There we go. So here I have a triangle, and it has 3 angles in it. Let's pretend like this angle right here is 100 degrees. Just gonna make up some numbers. If that angle right there is 100 degrees, I'll pretend like this one's 50 degrees. I'm not gonna get out a protractor and measure it. Just giving you a for instance example. Let's say this one's 30 degrees. Okay, so those are the 3 angles in this triangle. I could call them angle A, B, and C. Right now, those are the interior angles of the triangle. We don't really even mention that they're interior because that's all that you have, right? You've got these 3 angles, and I know the measure of them inside the triangle. Like, in other words, if going around a circle on angle C, it's gone 50 degrees. Okay, so that's what those numbers mean. And then here I'm going to try to show you what is an exterior angle. It says here an exterior angle is formed by one side of the triangle and the extension of an adjacent side. So in other words, if I made the triangle, this side here, side AC, if I made it longer, right there, if I made that side longer, then now I have created an exterior angle. This exterior angle right here actually forms a linear pair with the angle that was on the interior. See, this is the picture they give us. The picture without any angle measures, just with naming angle A, B, and C, and they're calling the measure of the angle A to be like that one. They're calling it angle 1, angle 2, and angle 3. They decided on their picture they would make side AB longer and create this angle 4 on the outside. So that's just to point out the difference between the interior part of that angle and the exterior part. So this part right here, if I can write the word exterior, if I could type it, exterior angle. Okay, so this is the exterior angle right here. And guess what? It is, I know that it's 130 degrees because in chapter 1, and we've been going back to it every now and then, so if you didn't learn it all the way in chapter 1, maybe you'll get it as we go along. In chapter 1, we learned that if you have a straight line and it's cut into 2 different angles, they're called a linear pair. The way they defined it was if you have 2 angles that have a common vertex, a common side, and then the 2 non-common sides form a line, then they're a linear pair, and the 2 angles have to add up to 180 degrees. Okay, that's a fun fact. That's something we know. Okay, now the new thing is to say that the measure of the exterior angle, so my exterior angle, oops, I'm going to move this word here so I can make a sentence. My exterior angle is going to equal measure of angle A, pretend like that's an angle symbol, plus measure of angle B. Okay, so remember how I stole that word exterior angle from here where I wrote that 130 degrees, because that was the exterior angle that I created with this triangle ABC. And the measure of the exterior angle, I didn't write the word measure, the measure of that angle is going to equal the sum of the measures of the 2 angles that it's not touching. That's why they're called remote, because they're far away, and they're interior angles. So in this example, angle 4 was formed by making this side longer, and angle 4 was adjacent to angle 2. So 1 and 3 were the remote interior angles. In this triangle, they made this side longer, so angle 1 was considered to be the exterior angle, and that measure is going to equal the measure of A plus B. Those were the 2 angles that it's not touching. They're called the remote interior angles. And when I started this example, I just drew the red triangle and I put in measures of angles that looked more or less correct, just to give you an idea, like, okay, a triangle, the interior angles add up to 180. And now can you see that, okay, this exterior angle that I told you, I can see that it's 130 degrees based on something I learned in chapter 1. Now using this new information, does it equal the measure of angle A plus the measure of angle B? Yes, it does. Why, yes, it does. That's kind of like what a proof does. It proves that something's true. Okay, so right now I was trying to prove to you why this exterior angle theorem works. And I also wanted to give you an example that had numbers in it because I feel like that's a little bit easier to understand. And then here they are proving it to you using a proof that we haven't learned yet, but we will learn it before the semester is out. And then it moves on to the corollaries that I already talked to you about, the triangle angle sum corollaries. And then there's problems to do, right? And I decided that I would use these check for understanding problems to kind of like go over, instead of having a PowerPoint with an example and click, 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 they solve it. Okay, so for number 1, find the measure, okay, for number 1 and 2, it says find the measure of each numbered angle. So if you can see here, this is a picture of a window and it's triangular, and they said that this angle is 63 degrees and this angle is, oops, let me try to just trace this out a little bit. So the triangle is supposed to be like here. It goes from here to here to here. Oh my goodness, maybe I should have used the straight line tool. What do you think? Okay, so if this angle is 63 degrees and this angle is 59 degrees, what you do is you add these two together and then you subtract from 180 to see what's left over, and that's the measure of angle 1. So in this case, 63 plus 59, well, that's going to equal 63, 72, 122. And so then you take 180 minus 122, and that gives you 58. Yes. Okay. So that's how you would do number 1. Number 2, they made it a little bit more interesting, and it says find the measure of each numbered angle. So you are going to need to find the measure of angle 1, which they're showing you it's this angle A up here, and angle 2 is going to be this angle right here, and angle 3 is this angle right here. Okay, so to find the measure of angle 1, you're going to use that corollary that came with the triangle angle sum theory. So that corollary stated that the acute angles of a right triangle add up, are complementary, which means they add up to 90. So the measure of angle 1 plus the measure of angle B, which is 48 degrees, that will equal 90 degrees. So that's how you would set it up. You might not even need to write that one down because basically you're going to take 90 minus 48. So the measure of angle 1 will be 42 degrees. Okay. And now to get the measure of angle 2, you have to notice something else. You have to notice, let me just take, I'm going to do this thing. Oops, I still have I'm going to do a thing. I'm going to show you that I only want to see this part right now. I don't even want to see that. Look, I just want to see this part of the figure. I'm going to do clear all drawings. Okay. So if I just look at this part, notice that I have, oops, a parallel line, a pair of parallel lines, excuse me, you can't have one parallel line. And then I have a transversal, and angle 2 and this angle are alternate interior angles. So in other words, this angle and this angle are alternate interior angles. If you didn't notice these two little pink triangles, the two pink triangles, the pair of pink triangles, those two indicate that those two are FC and ED. They're parallel line segments, which are part of parallel lines. And FD is part of a transversal. That's how I'm going to know that the measure of angle 2 is going to be 39 degrees. Okay, I'll write that in there real cool like. Okay, so that's 39 degrees. and that's going to be the measure of angle 2. And we knew the measure of angle 1 because A and B are the acute angles of a right triangle. That's the same concept you're going to use to find the measure of angle 3. Angle 2 and angle 3 are the acute angles of right triangle FCD. In case you need to know how to name a triangle, you would call it, look, I'm using the straight line tool this time. Triangle, if it says name a right triangle, I would say triangle FCD is, oops, capital letters, triangle FCD is a right triangle in this picture. And I didn't color coordinate it, sorry. But it doesn't matter what letter order you put the letters in, just so long as you use the right letters. So triangle FCD is a right triangle, and so therefore the measure of angle 3 is going to be 51 degrees, because 39 plus 51 equals 90. All right, and then, oops, goodness. So in number 3 and number 4, these are from example 2, that second concept that you're supposed to try to get a hang of in this in this section. And these have exterior angles in them. And so angle 1, this angle that says it's 112 degrees, that's the exterior angle. So the measure of this angle is going to equal the sum of the remote interior angles. So remember that this angle is formed right here. It's adjacent to this one. So I don't use that one. I use this angle and this angle. These are the 2 remote interior angles in this situation. So just erase those. So the equation that I set up, or the thing that I'm thinking about in my head, so I know what to subtract, is I'm going to say 112 degrees is going to equal the 2 remote interior angles, which is the measure of angle 2 and plus the sum of them, plus 32. Or maybe you were just thinking, well, I know that since 112 is going to equal these 2 added together, maybe I'm just going to take 112 minus 32. That's fine. The answer for number 3, the measure of angle 2 is going to equal 80 degrees, because 80 plus 32 gives you 112. And in this case, and number 4, they give you 2 angles inside triangle MNP, and then this side right here of the triangle, that's the side they made longer. So this right here is the exterior angle. So the measure of angle MPQ, remember how you name an angle, the middle letter is the vertex, and the M tells me that's one side of the triangle of the angle, and the Q tells me to go that direction. That's how I knew this is where the angle would be. So the measure of angle MPQ is going to equal the sum of the remote interior angles, angle M, which is 56 degrees, plus angle N, 45 degrees. Okay, and if you add those 2 together, you're going to get 101 degrees. And I'm not going to do 5, 6, 7, and 8. It's more of the same, where you're using the fact that, well, maybe I should mention it though. So if they give you, okay, so I decided to do them. If they give you the measure of angle 1 is 95 degrees, I guess this would show up better. Angle 1 is 95 degrees, right? That's 95 degrees. And that is the exterior angle. So 95 degrees is going to equal the measure of angle 4 plus the measure of angle 3. And guess what? They gave me angle 3 is 55 degrees. Ugh. So let me use the typing of letters tool so that you can actually maybe see what I'm writing while I'm writing it. So what I will know is the measure of angle 1 is going to equal the measure of angle 3 plus the measure of angle 4. And the measure of angle 1 was given to me, it's 95 degrees. And that's going to equal the measure of angle 3, which was given to me, which is 55 degrees, plus the measure of angle 4. That's what I'm looking for. So angle 4 is just going to be 40 degrees, because 40 plus 55 gives you 95. So that's how you do the first one. And they're all a little bit like that. Like maybe they'll ask you, now that you know the measure of angle 4, you could easily find the measure of angle 2, because 55 plus 40 plus the measure of angle 2 has to equal 180. That's a triangle angle sum theorem. That's how you could get that answer if I assigned this problem. Angle 6 and angle 3, those two have to add up to 180. They form a linear pair. That's that thing from chapter 1. So for number 6, you could find the measure of angle 6 by taking 180 minus 55. That would be 125 degrees. So that's on all of these problems where they have triangles within triangles. You'll be doing things like that. You'll be thinking about, okay, are all of the angles inside the triangle? They add up to 180. Are we talking about two adjacent angles that share as common side and the other side forms a line? Those are going to add up to 180. Are we talking about a right triangle and angle 1 and the 29-degree angle? They have to be complementary because this is a right triangle. So you would just take 90 minus 29 to find the measure of angle 1. Do you also see, and then you also have to do this thing you're learning to get better at in geometry, which is what if you just looked at, oh, I need to change the color so we can actually see it. What if it's this side right here and this side right here? I'm going to put a little bit on the outside so you can see. What if I ignore that line in the middle? Notice that that is a big old right triangle, and if I ignore the part in the middle, what if I draw on it with white, like try to make it disappear? Like, what if that's not there, and this isn't there, and this isn't there? Then I can tell you that the 17-degree angle and angle 1 and angle 3, those three angles have to add up to 90. And a minute ago, I said that you could find angle 1 easily because these two add up to 90. Okay, so that's kind of how you're going to be doing the problems in this section. Let's see if there's anything else I needed to mention to you. I think I covered everything. The only type of examples that I didn't give you were, let me zoom out a little bit, were any that had algebra in them. Oh, also to remember, like for example, for number 15, zoom in again and go down to number 15. Remember that angle 1 and angle 2 will be equal in this situation because you have this line right here and this line right here. Oops, scoot that up a little bit. And they intersect at point N, and so those two angles that they formed, angle 2 and angle 1, are called vertical angles, so they'll be equal. So once you find the measure of angle 2, that's what I would start with, because this is this right triangle right here. They gave me, this is 31 degrees, so angle 2 has to be 59 because 31 plus 59 adds up to 90. Well, I know that angle 1 is going to equal 59 because angle 1 and angle 2 form vertical angles. And so then this is 59, and then 59 plus 22, whatever that is, you take away from 180, and then that'll give you angle 3. You're going to end up to get 99 degrees for that if you wanted to mess around with that. So I wanted to make sure there wasn't anything else I meant to go over. Because I know I was going to also show you that some of them have algebra, and I did assign some of those. Like for example, for number 21, and it gives you a step-by-step solution in the back for number 21. Let's see, is it here? Oops, oops. Oh, it's a video. That's neat. I'll let you look at that if you want, but I'll let you know that the measure of the exterior, okay, so in this triangle ABC, this side right here is the side that they made longer. That means that this angle right here is the exterior angle. So 148 degrees, the exterior angle equals the sum of the remote interior angles. So 148 is going to equal the measure of angle A plus B. Notice how those are the remote ones. They're far away from this angle C. So this is going to equal the measure of angle A, oops, plus the measure of angle B. So you're going to end up, and I'll change it to typing so it's easier to read it. What you're going to end up doing is you're going to end up having 148 and set that equal to, what is the measure of angle A? It's 2x minus 15, 2x minus 15. And then that's going to be added to the measure. I'll change the color on us. Let's see if that, oh, nope, it doesn't work. It just changes the color of the whole thing. Anyway, that's going to be added to the measure of angle B, and that's x minus 5. Okay, so now I have an equation that I can solve. Although, if you're stuck on this part, that's algebra 1 that you need to work on. Okay, if you don't know how to solve this, then that's some algebra 1 stuff that you need to work with. The final answer should be x equals 56. I think the answer is going to be x equals 56. Well, why don't we just do it? Okay, so the next step would be 148 equals, see, what you do next is you simplify everything on the right side, okay? So the 2x and the 1x, they can be combined. That's called combining like terms. You get 3x. And then the negative, I know it says 2x minus 15 plus x minus 5, but right now I'm combining like terms. So this 15 is negative and the 5 is negative, so I'm adding negatives, so I'll get minus 20. Okay, and now I only have one term in my whole equation that has an x in it, and it's this 3x. So I'm going to leave that alone right now. And this negative 20 needs to be combined with this 148, but there's an equal sign in the way. So algebra teacher hopefully showed you that means that I need to add the 20 to both sides. Notice how I didn't do anything to both sides on the first step. The first step, I used that time to simplify everything until I couldn't simplify them anymore, like the right side and the left side. On the right side, I simplified it as much as possible. Now I'm doing the algebra stuff. So I added the 20 to both sides. So now I have left 3x equals, when you add that together, you get 168. And 7 and 8 is 15. So it's going to be divisible by 3. When you divide by 3, you will get 3 goes into 16 5 times, 15 remainder 1. Yes, it is going to be 56. 56x. What? When kids do that all the time, they'll be like 56x. I just didn't write the equal sign. 56 equals x. Okay. Notice how they're not asking you what x equals on this one. They're asking you what's the measure of angle ABC. So angle ABC is this angle ABC. So it's this. So if I put a 56 in here, 56 take away 5, that's going to equal 51, and that is the correct answer for number 21. So I did one of them for you. And it also, but it's the one that has the green circle on it. So if you click it and watch the video, you'll see if they explain it different than me or the same. Now I feel like you should be ready. I didn't assign you 24 through 29, and I really like them. Okay, but it's pandemic, so I'm trying to pick nicer problems, easier problems. But that one's pretty fun. If you wanted to play around with that, you could ask me for the answers later. And that's it.